Okay, so now we're going to talk about group theory problem 1 from the January 2024 qual. And this problem says let G be a group of order p to the third power times q with p and q distinct primes. And we're going to suppose that none of the Sylow subgroups are normal in the group G. And the first part is we want to prove that the number of Sylow p subgroups is equal to q, and that the number of Sylow q subgroups is equal to p squared. In part B, we're going to prove that this forces p to be equal to 2 and q to be equal to 3. And then in part C, we want to prove that G is isomorphic to S4. So for the proof of part A, we first observe that there are no normal Sylow subgroups. So the number of Sylow p subgroups doesn't equal 1, and the number of Sylow q subgroups doesn't equal 1. So because the number of Sylow p subgroups has to divide q, and since q is prime, this forces the number of Sylow p subgroups to be equal to q. So we have the first part. Now, the next thing to observe is that the number of Sylow q subgroups is equivalent to 1 mod q, and that the number of Sylow q subgroups divides p cubed. So this forces the number of Sylow q subgroups to be either p squared, or p cubed, because it's not 1. So now we're going to let the number of Sylow q subgroups be equal to p, and we're going to fix a q in the Sylow q subgroups of G. So now by Sylow's third theorem, we know that the index of the normalizer of q and G is equal to the number of Sylow q subgroups. So that's equal to p by supposition. And now p is the smallest prime dividing the order of G, because, well, the group is of order p cubed times q, and so p is the smallest prime dividing it. So there, by a theorem that we've proved in class, this means that the normalizer of q and G is normal in G. But this cannot be, because there are no because that would make q a normal Sylow subgroup of G, and so the number of Sylow q subgroups can't equal p. So now, suppose that the number of Sylow q subgroups is equal to p cubed. Then there's p cubed times q minus 1, which is equal to p cubed times q minus p cubed elements accounted for in Sylow q subgroups. So this leaves only p to the third power many elements in G, and this forces the number of Sylow p subgroups to be equal to 1. But we said that can't be the case. So the number of Sylow q subgroups does not equal p cubed, and so as a consequence, that forces the number of Sylow q subgroups to be equal to p squared, because it's not 1p or p cubed.